One of our big topics in this unit is deriving the equation of a circle. So I drew a number line right up here at the top of the screen. If I want to know how long this segment is from -1 to 3 on my number line, I could count, but I could also just subtract. So I could subtract 3 minus -1 and I would get 4. So let's keep that in mind. Let's go over to this circle. And when we're talking about a circle on a graph, we use the letters H, K to represent the center. So I'm going to label my circle center as H, K. And any point on the circle could be represented with the ordered pair X, Y. So I'm going to just pick a point over here. I'm going to deliberately pick a point where I can't really tell what the ordered pair is from the graph. I know it's, I could estimate it, but I'm going to just kind of arbitrarily choose this point. And I know that the segment that connects the center to any point on the circle, we call that the radius. For this particular circle that's on the screen, I know that my center is located at -2, +2. So for this circle, I'm going to just write on top of it, the center is at -2, 2. And I could use a nicer point on the circle to tell that the radius is exactly 3. So my center is at -2, 2. My radius is at 3. So to derive the equation, I need to really break down the path from the center to any point on the circle into a horizontal path and a vertical path. So if I move horizontally, I'm moving in the direction, like I'm moving parallel to the x-axis. And as I move vertically, I'm moving parallel to the y-axis. And we get this nice right triangle. I'm going to pop that triangle out in because I think it'll be hard to see on the graph, and I'm going to sketch it over here. All right, so here's our nice right triangle. So we said H, K is going to be the center, and this X, Y is going to represent a point, and this distance from the center to the point is our radius. So if I go back to that idea of a number line, if I want to represent how long this horizontal distance is from the center just horizontally to that point, I could, using this idea up here, I could say, well, hey, that distance is whatever this x coordinate is minus whatever this h value is. So I could call this x minus h. So just like up here, the length of this is 3 minus -1. I can do the same thing for the y values. So this vertical change from the center vertically up to the point is, I know the value on top is a y value. And then this down here at the bottom would be k. Oops. So I could write y minus k for that piece. So now if I look at this, I have a right triangle where all 3 sides are labeled. And there's a theorem we've worked with a lot this year that we know relates the 3 sides of any right triangle. And I hope you're saying it with me or in your head. We know that that is the Pythagorean Theorem. Hands down, one of the most important things that we learn in geometry. So for any right triangle, if the legs are, say, A and B, the hypotenuse must be C. We know that a squared plus b squared equals c squared. And we said that's just the Pythagorean theorem. All right, so going back to this particular right triangle that's in this circle, if I wanted to write a relationship that links the 3 sides of this triangle, I could use the Pythagorean theorem, and I could say that x minus h, so that's just one of the legs, the length of one of the legs, I could square that. So that's like my a squared plus y minus k, square that, that's my b squared. equals the hypotenuse squared, or the radius squared. And this is the standard form of the equation of a circle. So if we want to write the equation for this particular circle that's on the screen right now, we are given the center. The center is -2, 2. So I would write x minus my h value, -2 squared, plus y minus my k value, so h comma k again is our center, y minus 2 squared, and that will equal our radius squared. Well, we said the radius is 3. So the last thing I would maybe do here is I might just rewrite that simplify this a little bit. So x minus -2, we could actually write that as x plus 2. And then we would just leave this as y minus 2 squared. And then 3 squared, of course, we know is 9. So this would be the equation for this particular circle that is on the graph. You won't have to derive the equation using the Pythagorean theorem every time. That would be kind of a pain. You can, but you don't have to. What we really just need to get from this, I want you to understand where it comes from, but what I really need you to just walk away from this with is that the standard form of the equation of any circle is x minus h squared plus y minus k squared equals the radius squared. And this comes from the Pythagorean theorem. We said h comma k is the center and r is the radius. So something to keep in mind is that when h and k, like when there is subtraction here, the center is positive. All right, that's all I've got for this first introduction.